points A and B have coordinates 2, -3 and 4, 1 respectively. The line L has equation x plus 2y minus 11 equals 0. Find the equation of AB and simplify your answer. Show that AB and L are perpendicular. The lines AB and L intersect at the point C. Show that C has coordinates 5, 3. Find the lengths of AB and AC, hence find the value of the constant k such that AB equals KAC, giving your answer in its simplest form. Okay, that's the question then. I've summarized it here. So first of all then, find the equation AB. Here's A and here's B. So here then, y minus one of these coordinates here, we'll take the 1, is equal to the gradient times x minus the x value at b, 4. Now the gradient of AB, the increase in y is 1 take away minus 3, is 1 plus 3 is 4. That's the increase in y. The increase in the x's is 4 minus 2 is 2. So just again, 1 minus minus 3, the difference in the y's is 4. The difference in the x's is 4 minus 2 is 2. There's the gradient then, 4 over 2. So that tells us then, this is just y minus 1. This is 2 of course. Expand the bracket, 2x minus 2 4s are 8. So that tells us now then that we've got 2x, move the y over, minus y, and also move the 1 over to plus 1. Minus 8 plus 1 is minus 7 equals 0. So there's our equation then. So it was 2x, move the y over to be with it, becomes minus y. Move the 1 over to become plus 1. Minus 8 plus 1 is minus 7. So there's our equation for part A. Show that AB and L are perpendicular. So part B. So the gradient of AB then. Well, if we write this in the other form, so I'm just going to put it here, move the y over. Y is equal to, move that over there, 2x and minus 7. So I've moved the y over, and I've written it down from right to left. The 2x minus 7 stays as is. The gradient of AB is 2 then. The gradient of L, now L has this equation here, let's just get it. X plus 2y minus 11 equals 0. So let's just do the workings over here. X plus 2y minus 11 equals 0. So that tells us that 2y is equal to minus x. Move that over. And move the 11 over to become plus 11. Divide by 2 all the way through. So y. Half of this is minus a half. And then plus 11 over 2. So the gradient of L from here is minus a half. Since 2 multiplied by minus a half, the product of the gradients is minus 1. The lines are perpendicular. Okay, that's part B. Now part C. A, B and L intersect at C. Show that C has these coordinates. Okay, part C. AB, the line AB, which we've got here. So we've got y is equal to 2x minus 7 written here. We've also got y equals, for the line L, minus a half x plus 11 over 2. So there's our two lines. So they intersect when the y values are the same. So 2x minus 7 then is equal to minus a half x plus 11 over 2. So we've let this side equal this side to see where they intersect. Move this over here. So it becomes plus a half. So 5x over 2 then, 2.5x's. Move the 7 over is plus 7, which is 14 over 2. Plus the 11 over 2 that's there is 25 over 2. The other way to think about it is 7, and this is 5.5 is 12.5, when this is moved over to become a plus. 12.5 is 25 over 2. So that tells us then that 5x cancelled by 2 both sides, or multiply both sides by 2, it's the same thing. 5x equals 25, so x is equal to 25 over the 5, isn't it? Move the 5 from times down to divide. So x equals 5. Also, well, if we look at y then, 2x minus 7, 2x minus 7, the x value is 5. 10 minus 7 is 3. So C has coordinates then. The x value is 5, and the y value is 3. So that's part C done. So find the lengths of AB and AC, hence find K. Okay, our coordinates then. We need our coordinates of A and B. 2 minus 3, so I'm going to copy this here. Let me just copy it. Okay, and then paste it in, and we'll take it down. And we need to find the two lengths, don't we? AB and AC. So here's our coordinates. Let's just move them down for part D then. Just move us down to give us some space. And this is part D. There's A, B, and C is equal to 5, 3. So the length AB then. Well, let's just do, it's the square root of the other two sides, difference in the sides squared, isn't it? So it goes from 2 to 4, so that's 2 squared is the difference. Minus 3 to 1 is a difference of 4, so it'll be 4 squared. 16 plus 4 is 20. Root 20, which is the square root of 5 times 4, which equals root 5 times root 4. And root 4 is 2, so it's 2 lots of root 5 then. So there's the length AB. The length, now what did they want? BC? Let's just go back up and check. AC we want to find. Same again, square root Pythag, the difference between the sides. A to C is a difference of 3, so that'd be 3 squared. Minus 3 to 3 is a difference of 6, so that's 6 squared. 36 and 9 is 45. So it's the square root of 45, which is the square root of 9 times 5, which is the square root of 9 times the square root of 5. 3 root 5. So AB is equal to 2 root 5 is equal to k lots of AC, which is 3 root 5, implies, well, k would need to equal 2/3, wouldn't it? That's what we see there, coming from that simple, straightforward thing. The only thing, was it AB equals KAC? Let's just go back and check. AB equals KAC. Yeah, that was fine. And we found K in its simplest form. So here K was 2/3. So what we could have done was we could have striked off the root 5s and moved the 3 from times to divide. We'd have got 2/3. Or you can just look at this. To make this value 2, we need to make K 2/3, don't we? So there's our value.